Well, hello again, it's Cliff here from Down Under. In this video I'm going to be machining some tough tool steel. I'm doing a short production run, a pilot production run of these new Tormach lathe tool setters, machining up the bodies and some cavity machining, blind machining in tough tool steel. A few tips and tricks along the way that might be of interest. Cheers. Just starting a production run for Tormach of the new lathe tool setter, and I'm machining some alloy steel parts and doing some internal production machining of steel. I'm machining two sides of this new lathe tool setter, and I'm comparing adaptive roughing with conventional machining strategies for machining pockets in steel, in alloy steel, and I'm curious as to which is going to be the best for metal removal and tool life. In this test, on this side, I'm using adaptive roughing. You know, that's where you have a deep depth of cut and a very small step over and a series of climb milling scallop cuts. So I'm going to see how that goes compared with conventional machining tool path. Just to be clear, if you're not familiar with adaptive roughing, this is when you're cutting a pocket, for example, or a slot. The tool's moving crossways with a small step over. So the step over is, for example, a 20% step over is that amount, cutting in that direction like that. So we're cutting crossways there. Don't confuse step over from depth of cut. Just quickly sketched it out to explain this a bit better. So depth of cut is the Z depth of the cutter. The step over is the depth of cut, if you like, in the X and Y, but don't confuse that with the feed rate. The feed per tooth is the actual chip load. For example, if you had 1 thou feed rate or a 0.03 in metric times the number of teeth times the RPM for steel, for example, you might get a feed rate of 480 millimeters a minute, equivalent in inches. So we have feed rate or feed per tooth, we have step over, and we have depth of cut. Be careful not to confuse those. So that is adaptive roughing. And it allows for a much deeper depth of cut and better utilization of the end mill. There are other advantages as well. I wanted to see, when machining alloy steel pockets, whether conventional machining is better or adaptive roughing is better. When you've got a small amount of step over and a large depth of cut, there's some real advantages with that because you're using a greater length of the tool and getting more value out of your tool. But there are advantages with conventional machining too, in that you can resharpen the tool very easily, as I explain in this video, and allows you to get a lot of turns with your cutter. But there are additional advantages with adaptive roughing for machining steel pockets. Really, an important thing with pockets machining steel is that you evacuate the chips. You must flush them out. You must minimize the amount of re-eating of the chips. And the type of chips that come off with this type of machining are finer and longer, and they seem to have a bigger surface area, and they are more effectively flushed out. And I think that's the most important feature for machining steel pockets, is which strategy gives the best flushing of chips. And I think the adaptive roughing wins on that, because these little chips are small in surface area and they don't all flush out, and some of them get between the chips, between the cutter and the work, and that very quickly breaks down the edge, makes a horrible crunching sound. If you listen to the adaptive roughing machining, you get less of that. So with adaptive roughing, the chips are long and thin and light, and with conventional machining, the chips are short and thick and heavy and do more damage to the cutter, all other things being equal. Well, that went really well, that test of adaptive roughing. I know there are some skeptics that think that adaptive roughing doesn't really work on a very light, slow machine like the Tormach. You really need a high-speed machining center to take advantage of adaptive roughing. And while that may be true for some jobs, it very much depends on the material you're cutting, the size of the work, the size of the cutter, and so there will be advantages in using adaptive roughing on a light machine like a Tormach in some situations, and it definitely is an advantage for pocket machining of alloy steel, because it gives you better chip evacuation, and that is key to getting good tool life. And not only does it give you better chip evacuation because the chip is of a bigger surface area, but because the chippers are of a longer length and thinner in section, it's going to have less impact on the cutter if it gets between the cutter and the work. So if it doesn't evacuate, it'll be less harmful than conventional machining strategies that have a smaller, thicker chip, which is going to do more harm to the cutter. Of course, there's multiple variables here, and there's no hard and fast rule. It is very much dependent on the job, the material, the size of the work, and the machine. I'm not showing you close-ups of this tool setter because I want to keep some of the internal IP a little bit private, but I'm using it as an example of toolpath strategies. So on this side I used the adaptive roughing, and to be fair, it's a little bit of an unfair comparison because it's an open pocket and it's much easier to flush out of an open pocket. On the other side, where I used conventional machining, it was a closed pocket, and I really need to redo that toolpath with adaptive roughing and see for sure whether it's better. It's just my gut feeling that it will be better. Next time I run these lathe tool setters, I'll change that toolpath to adaptive roughing, and then I'll know 100% whether it is better, but I think it will be better. But you may not have the software that allows you to generate adaptive roughing toolpath, or you may be comfortable for a small amount of machining that you do to stay with conventional toolpaths with a shallow depth of cut and a small chip. And there are some advantages with this in some applications. So in this video I'll go on now to outlining some of the ways that you can capitalize on this type of toolpath and resharpen your cutter very easily and get more mileage out of your tooling. Fine-tune the RPM to eliminate chatter. It's bad there, but it's nice and quiet there. Another trick is to use a roughing and a finishing tool and touch up the roughing tool with a chamfer shaped resharpen by hand when it becomes blunt. Sure, it's changing the shape of the roughing machined pocket, but the finishing tool takes care of that anyway, and the finishing tool is going to last a lot longer if it's not machining out much metal. So it's really worth having a roughing and a finishing tool and sharpening the roughing tool regularly. Another trick is to keep the cost of your tooling down by buying tooling whenever possible that is in the sweet spot of low price. You know, small diameter carbide tools are quite low price because the carbide blank is cheap and the grinding process is quick and easy, up to about 1/4 of an inch. And that's a sweet spot. 1/4 of an inch or 6 mil, the cost is still low. You go up to 8 mil or 10 mil, the price suddenly becomes a lot. So that's worth taking advantage of whenever possible. You may know that one of the problems with machining steel, alloy steel, particularly if it's a blind pocket, is that the cutter tends to re-eat its own chips. Even with high pressure flush cooling, a small percentage of chips will occasionally get between the cutter and the work, and that breaks down the cutting edge really fast. So it's usually the first 1 or 2 millimeters that breaks down, because you can't take large depths of cut with tool steel without causing a lot of chatter. So you're going to break down that first 1 or 2 millimeters. If you have a slot drill, it's quite easy to, with a diamond lap, stone and sharpen it on a bit of an angle, about 20 degrees to the axis, each time it gets blunt, and then you can press that cutter back into service again to machine a few more parts as a roughing cutter. Alright, let's just have a look at that now. So what happens with the cutter when it's eating chips? It starts to break down around this area here, and it very quickly breaks down once it starts to get blunt. So you want to catch it early before the cutter gets too damaged, and stone with a diamond lap like that, an angle like that there, to reintroduce a nice sharp cutting edge. And you can even break that angle slightly too. And there's a double advantage here, because the cutter is now sharp, and also the angle of cut is not this way anymore, but it is this way now, and that puts a lighter load on the cutter. Sure, it's leaving a little bit of metal behind, but your finishing cutter is going to take care of that. So that angle, that slightly chamfered angle, is a better shape for the life of the cutter and the stress on the cutter. Okay, let's just look at how you might do that. Be a bit tricky to show it on camera, but just roughly. So you get a diamond lap, for example, this Easy Lap Super Fine. Bring it up onto the cutting edge. Set your work with aluminium jaws in the vise so that the cutting face of the flute is horizontal. It's easy to see then. Bring your lap in on an angle until the gap disappears, with a spot of kerosene on it for lubricant. And you can sort of see the gap if you get the light right, until you've got just the right clearance angle on there, and then just lap it like that. It very quickly cuts. The diamond lap will very quickly cut the carbide, and you'll see a nice sharp edge appearing. Well, this 6mm slot drill has been sharpened several times now, and you can see there's quite a pronounced angled, beveled edge there. It's still a perfectly good cutter and can still make many more parts. Diamond grinding wheels are really cheap nowadays, and you can buy a used one or a Chinese one for a very low cost and put it on a cheap little bench grinder, and that way you can sharpen even more quickly, and you can back off as the beveled land becomes big and hand lapping starts to take too long. Really worth investing in one of these. Be careful not to breathe in the dust. I don't breathe for the few seconds that I'm using it, or you could wear a mask. Here you can see the back off that little flat on the end. So you need to keep that back off there so that the heel of the cutter doesn't drag and cut. That becomes quite a big job by hand lapping once your cutter starts to get worn, and actual grinding wheel speeds up that process. But if you're just trying the idea out, you can get several resharpens with a hand lap, see how you go with it. If you like it, then you might want to invest in a little grinding wheel and grinder. And remember, with these low-cost, lightweight machines like the Tormach, even the 1100, they're very little cast iron and they're not very rigid. You can't machine with large cutters, carbide cutters. You can't machine steel efficiently. The vibration will break the cutter down too fast and you'll be wasting your tooling. You need to be using relatively small cutters to get the best out of these very light machines. Sure, you can go up a bit bigger, and probably a 3/8 would be an optimum size, but they become quite a lot more expensive. Obviously, it really helps if you have high pressure flushing with at least 2 nozzles coming in as close as possible to the cutting edge to blast out as much of the chips as you possibly can, and that will cause a bit of spray in all directions. So it's a good idea to have a cover over your electrical cabinet if you have an old series Tormach like this one, a simple little plexiglass hatch over it to keep the spraying coolant from getting to the electrics. I've done a video on this little simple addition. If you go back several years, you'll find a video, one of my first videos, coolant proofing your electrical cabinet or something like that. Just a quick note regarding high pressure coolant flushing. You really want to avoid getting coolant up into the spindle bearings and washing out the grease and getting dirt and chips into the spindle bearings. So I've done a video on this a while back. It's a acetyl disc mounted on the end of the spindle, which completely covers the open end of the spindle bearing entrance, and there's a little bit of a gap there, and that's an additional baffle. There are internal baffles with these Tormach machines which slow down the ingress of coolant, but they are somewhat limited, and I think the coolant can still find its way through if it's enough pressure at the right angle over time. So I would recommend, for the small amount of work involved, machining up an acetyl disc and having additional cover. There's a video on this a couple of years ago showing the design and construction of those, but you can see there it's just a simple acetyl disc. While I'm on this subject, I see a lot of videos showing a very poor surface finish, and often it's because the very corner of the cutter has become dull. This happens very quickly. You won't hold a 90-degree edge for very long at all. It's just too weak, and you'll have a very small blunt radius on that edge, and you know, there won't be any clearance there. It'll be a blunt edge, and it will be cutting intermittently, and you can see those telltale signs of rubbing and cutting and rubbing and cutting, showing a poor surface finish. And you can resolve that even with a fairly new cutter, grinding with the lap a very small 45-degree chamfer at that point. Now we're talking, I've drawn it much bigger to exaggerating, but we're only talking a 2 or 3 thou chamfer, and that will produce a much better surface finish, a more durable cutter, and a stronger shape than a very fragile 90 degrees. It's that last 2 or 3 thou that crumbles away very quickly, and you get this very blunt radius with negative clearance that gives you that poor surface finish. I'll see if I can show you those tiny little flats there. Well, you can just about see it there now. Obviously you're going to be lapping through the coating surface, so you might not want to do this on a brand new cutter, but when it begins to get a little dull, you can bring it back like new again. Right, thanks for watching. Cheers.